What we worked on in the first video was what is the Pythagorean Theorem and how do I use it to find missing side lengths, whether the hypotenuse is missing or one of my legs are missing. What we're going to do right now is not anything different, but the problem might look different right when you look at it. So we are going to have an equilateral triangle where all the sides are 12. And I am going to ask you to find, or the problem is going to ask you to find what the measurement of the height is. And I'm going to do this quite a few times. I'm going to use this for a specific color because when I'm given a problem like this, like I have two triangles going on, which triangle am I looking at, what's going on? I ask my geometry students to do this daily, like pick out exactly what it's asking you for. Like if I'm just asking you for the height of one of those triangles, this one or that one, then redraw it. Like put it over here so that you're not worried about anything else that's going on. It might sound tedious, but this little tiny movement of just separating it from the big triangle could be a game changer. So at this point, my hypotenuse is 12, but in order to use the Pythagorean Theorem, I need to use one of the legs. So what's going on? I know that if that is 12, then the height is half of it, so this is 6. And I'm looking for that height, or I'm looking for that unknown, which happens to be a leg. So I'm going to plug in everything. A squared plus b squared is equal to c squared. Take a second to think what you're plugging in where. I said I wasn't going to use the other colors, but our hypotenuse is always the c, or the side that's opposite the 90 degrees, the one that doesn't touch the 90 degrees. So it doesn't matter x or 6, which goes in for a. I always just pick x first because it's easiest. And then 12 squared. Okay, at that point, you've done, like the new part, you've done the Pythagorean Theorem. You now are just solving a problem that happens to have an x squared in it. So let's look at what that is going to do for us. 6 squared, I always want you to do this. I can't make you because I'm not there, but I promise you that that will pay off in the future when you're doing this stuff in geometry and algebra 2. So we're going to subtract 36 from both sides because that's going to get my x squared by myself, which is exactly what I wanted. Okay, still not done yet. Got to get x by itself. How do I do the x squared? What do I do to both sides? Square root it. X is equal to the square root of 108. Why am I not accepting that answer? Does anyone know? Technically, that's my answer. Like, if I was to type in the square root of 108 and get a decimal, like that would be an estimated answer or a decimal answer. But it's not simplified. What perfect square goes into 108? And you can spend some time saying 108 divided by 4. Oh, that does work, but that's 180. Whoopsies. 108 divided by 4, that does work. 108 divided by 9, nope, that does work too. There's got to be a bigger one. And that goes in 16 times, nope. 108 divided by 36. It's 36 and 3. 36 is the biggest one. So 36 and the square root of 3. And why do I like the square root of 36? Because it turns into a 6. And that is my height, or my missing measurement there. So let's look at another example where everything's given to you, but it might not look like that right away. So in this case, there is a rectangle. Here's the rectangle. One of the sides is 10, one of the sides is 18, and it says, or it wants you to find, or it doesn't actually say it, but it says, let's find the diagonal measurement. Let's find that x value. Again, my suggestion, I tell my geometry students do this every day when we're working with shapes, and I bet they would agree with me that, yeah, it might be super helpful to like redraw the actual triangle that you're working with, because then you're not worried about everything else. So let's label what we know. I know that this is 18. I know that this is my hypotenuse, and that's what I'm looking for. What's this side over here? And the key word that you might have missed was rectangle. I said this is a rectangle, and a rectangle's opposite sides are congruent. So those would both be 18. And if that's 10, this is also 10. I have everything I need in order to plug this into the Pythagorean theorem and solve it. So a squared plus b squared is equal to c squared. C is my hypotenuse. That is what I actually don't know in this case. A lot of people like that easier because they can just type in 10 squared plus 18 squared into their calculator and they have all of that taken care of. And that's squared. So 10 squared is 100. 18 squared is 324. X squared is, well, it's x squared. I'm trying to get x squared by itself. It already is. It has been for a while. We're just trying to simplify this down as much as we can. So I'm going to add those up. That's 424 is equal to x squared. At this point, square root both sides, and you have what x is equal to. But that's not the correct answer. I mean, it's correct, but it's not simplified. What perfect square goes into 424? 4 does, 9 doesn't, and I could kind of keep going. 4 is the only perfect square that goes into that. So the square root of 424 is 4 and 106. But why do I really like the square root of 4? Because it's just a 2. And that is your final answer. I prefer to write it on the other side, but that first one would have also been your answer.